Was there only 3 sections?
Yeah, I think so.
Really? Well, how about that? All right. Aiden and Aubrey and no, not Aubrey. Aiden and Mallory and I'm used to recording for you, Aubrey. Sorry, I'm just always say Aubrey because it's geometry. Okay. Number 9, we're gonna go over 5-2 homework problem number 9, and I figured I would record it because you're probably gonna want it, right? Say yes. Okay. Based on a poll among adults who regret getting tattoos. Okay, 22% that say that they were too young to get their tattoos. Okay, now, this is not saying 22% of all people regret getting tattoos. They're saying of the people who regret them, 22 say it was because they were too young. Another percent might say they were drunk when they got it. Or another percent might say, I broke up with my girlfriend and that's why I regret getting it, right? That type of thing. Okay, so this is reasons why we regret getting tattoos. 22% say they were too young. Okay, so what is 22% stand for? 0.22. P, right? That means Q is 0.78. So 22% regret getting tattoos because they were too young. That means 78% of people regret getting tattoos for other reasons. Okay, I told you yesterday when I label my P and Q, I usually always put like what they stand for so I can keep them straight, all right? Assume that 5 adults who regret getting tattoos are randomly selected. 5 is?
B, R, the first one, I don't know.
N. 5 is N. Find the indicating probability, so we don't know what R is until we read part 8. It says, find the probability that none of the selected adults say they were too young.
So 0?
So R is 0 for the first part, right? Okay, so I'm going to set up my polynomial thing, whatever, P of X equals NCR, P to the R, Q to the N minus R. Here we go. What does NCR look like? 5, C, 0. Brian's on top of it. P is 0.22 to the what?
0.
0. Q is 0.78 to the fifth. Those two have to add up to be N, right? Okay, if I do that, what do you get?
8, 9.
What?
0.289.
0.289, 28.9%. There we go, 0.289, okay? Find the probability that exactly 1 say they were too young, okay? So I go from 5C0 to 5C1. 0.22 to the 1. 0.78 to the 4th, right? Okay, if I do that, I get how much? If you like the labels and you want to put like P of 0 equals and P of 1 equals, that sometimes helps you keep stuff straight, maybe. Okay?
4.07.
4.07?
4.407.
0.407?
Yeah.
0.407, okay, 40.7%, right? All right, this says, find the probability that the number of selected adults say that we're too young is 0 or 1. Or means, what does or mean? Add, or means add, right? Okay, so I add those together and I get 0.696,
Yes.
or 69.6%, okay? Good. If we randomly select 5 adults, is 1 a significantly low number who say that they were too young to get tattoos?
No.
This is 1 or 0, right? Which is the number that we compare. What do we compare that guy to?
5%.
5%. Is that less than 5%? No. Not even close. So, is 1 a significantly low number? No, it's not significant. Not even close. Okay, make sense? Good? There we go, there we go. Wait. Wait. All right. We could go a couple different ways on this. All right, you guys want to start 5-3 or you're gonna pick the or, right? Okay. Or you guys have a formula sheet at the back of your thing. It's a colored one, right? It's like, I think I made it like pink or blue or something right there. Right there like that, right? Okay. And we could fill out these first 4 that has to do with the formulas. Do we want to fill those first 4 out?
Sure.
Yeah? On a Friday because we have shortened periods?
Yeah.
Yeah, because it usually takes us like 2 days to fill this thing out at the end of the chapter.
That's a great idea. Is this,
So we can fill this out, and I give you examples, and you actually have to do the examples and all the things, right?
So we're skipping lesson 5.
No, we'll come back to it next week on Monday, right? But we'll fill this out because then it will be a little bit easier to understand it. We'll hit it one more time before we go to the next section where we talk about the last 2 little bubbles. Okay. All right. So I have this guy, and I'm gonna erase some stuff. But before I do that, let me figure out what I want to keep.
Holy cow.
we should just copy what you have down.
No. I'm gonna leave some of it. Whoop, 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 whoop.
Carter, is this yours?
Yep.
There we go.
Put a name on that one too.
And we're gonna go here.
Billy, Ethan, Aubrey, Kenzie, Tate, Eli, Ryan, do you guys have your homework done?
Sorry. I have a few more projects for you to-
Do you want a new pile coming here?
Sure. Yeah, just put them sideways. The other way. You can put them on top of those.
Like on top of
Yeah,
this
yeah,
drum.
but the other direction. Yep. Okay.
The only downside is you can't use color on camp. But I'd still take
Yeah.
I'd still
Yeah.
keep the pink paper.
All right. So on your stats formula stuff. On this paper, what should we call this paper? Your pink paper? Your pink page? Pink page. Okay, on your pink page, this is your formula page. This is the page that you will get to use on your test because it has all the formulas that I don't expect you to memorize, right? Like, especially when it comes to like mean and variance and standard deviation of a probability table, like those are disgusting formulas. I do not expect you to memorize that. Now, this pink page we will add to, if you look at the back, it also has blocks on the back side because when we get to chapter 6, we will add to that, right? And we'll add more, some chapter 7, etc. We'll eventually get another sheet because we'll have too many of them, right? Okay, so here is what I want you to write down, just these first 4, and then we'll do those after we do section 5.3. But these first 2 have to do with section 5.1. These second 2 blocks have to do with section 5.2. Okay, so first of all, just section 5.1, we're doing mean and variance and standard deviation of a probability table. Okay? Mean, variance, standard deviation of a probability table.
So
Okay? And we will do that
Wait,
stuff.
is X R?
X's are,
Yes.
yes. Yep, X's always are. Mean, variance, standard deviation of a probability table.
So just the first 4 or just the first 3? Did you write the first 3 down? What's the names of the concepts for the 4th block?
Because it's covered.
Oh.
You can't see it.
What? For the 4th block? There you go. I'm thinking how I want to do this.
Oh, am I supposed to be doing those?
Yep, write these down. Just those first 4.
Are you supposed to draw an arrow from the 4th block to the 3rd block?
Can we do this in a different order?
Yeah.
Or do you want to start at the top?
You don't mess it up because we're not.
I'm not going to mess it up.
I wrote in pen, so.
Okay. All right. We're going to start with the 3rd one because that's what's fresh in our brains. And then I'm going to use that probability table to do this one up here. Okay? Okay. All right. Yep. Here we go. So we're going to start with this 3rd one. We're going to fill this one all the way in. And actually, when we do that, we're going to put a table up here, and we're going to use that table to find the mean and the variance and the standard deviation of that table. So all 4 of these will go with the same problem,
Do we
kind of.
write that example down then?
Yes, write that example down. Yes.
In the 3rd
All of this in the 3rd one. Yep.
Oh,
Okay.
Probability of what?
Okay. So we'll just start with the 3rd. Okay, example. Find the probability that Mrs. K kills a plant. Oh, the probability that Mrs. K kills a plant is 82%. If, can I switch those numbers? Let's go if 4 trees find the probability that 3 live. We'll make this smaller. If we have 4 plants or 4 trees or whatever, find the probability that 3 live. I'll make it smaller so we have a smaller table.
So my phone or your phone? My phone.
Yep, I'm going from 4 trees, find the probability that 3 live. Got it. All right, so let's fill this third one in, this third row in first. What? Okay. 4, find the probability that 3 live. By the way, real quick, if I have an 82% kill rate,
It's a pretty good KD.
that's I've got a pretty good kill rate for plants. And now I'm talking about 3 out of 4 living. Okay, if I have an 82% kill rate, what is the live rate?
18.
I have an 18% live rate, right? 18%, you don't have to write this down. I have an 18% live rate, right? But now I'm wanting to know what's the chances that 3 out of 4 live, which is a 75% live rate. Is that going to have a high chance of happening?
No.
Not going to be likely to happen. If my live rate is 18% and now I'm asking what's the chances that 3 out of 4 of them live, that's not going to be a very high chance, right? Do we understand how this works?
Yeah.
Okay, all right. Okay, let's go and let's fill in this, and I'm going to fill in the formula first, and then we'll pick apart all of the stuff that we need. So, this is the P of X equals NCR P to the R Q to the N minus R. There is what we have going on there. That is the binomial probability formula. There he is. I'm in the third row, right? We're going to do the third row first since I have the example, and then we'll use it for all the other examples, okay?
And this total.
NCR, P to the R, Q to the N minus R, okay? Let's fill in.
Total.
We have N, we have R, we have P, we have Q. N, R, P, Q. And I'm going to put this in the important information column, okay? N is, Josie said, the total number.
Oh, I smudged the E.
R is the what?
Is the number we're looking for.
The number I'm choosing, or the number we're looking for, yep. Okay. What is P?
That's the probability of whatever.
This is the probability of, they call it the probability of success, okay? But in our case, it's just like the probability that they give us, right? So like, I might say the probability of success actually corresponds to killing trees, right? Like my 0.82 would be probability of success, but that corresponds to killing trees, which isn't really success. But it doesn't matter which one you label, just as long as your exponents are correct that you attach to the formula, okay? So if this is probability of success, Q would be probability of failure, right?
Or
Okay?
P.
Or-
bar.
Whatever. It's kind of like P bar, actually. Yep, that's exactly what it is. Q is kind of like P bar, which is the
That's what
opposite,
I'm
whatever.
gonna label it.
But in this case, yeah. So anyway, there you go. Okay, that's all the stuff that I need. I want to find the probability of all this stuff. So let's go down here and let's figure out what N is. Let's figure out what R is. Let's figure out what P is. Let's figure out what Q is according to just this problem.
N equals 4, R equals 3.
N equals 4, R equals 3, P is
82.
0.82, Q is 0.18. Now, I would strongly suggest label what P and Q is. So P is
Kill.
kill, Q is
Live.
live, right? Or not kill, okay? So I label those so that way my P's, and I can switch those P's and Q's around if I want to, and it's not going to matter as long as I do it right in the formula. But I label them so I know which one is which, all right? So I want to define P of
4.
3. I'm trying to find P of 3, right?
Well,
3 live, right?
I mean,
P of 3, and so now I'm doing in the formula, it would be 4C3, yep. P,
P,
which is 0.82, and Q, which is 0.18. Now the exponent on the 0.82 is going to be, is it 1 or 3?
What? It's gonna be 1.
I'm right.
It's 1.
You just told us yesterday.
What is
it was
3 plus
only
3?
You
Is
said
3
it was
plus
the
3
same
6?
number.
Yes.
Nope.
It's gotta be
Nope.
4.
Nope.
So you have to
So
have 1
I
plus
want
3 is
3
4.
live, right? Which one of these is live? Live is here. So this has to be 3. This is die. So this is 1. Yeah.
Okay. Yeah, you did.
No.
I might have, yeah.
You said
Always
the same
said
number,
the 3
yeah.
is the first one.
You said said they were the same number.
You can switch it around.
You get, yeah. Yeah, maybe I did lie to you.
You did lie.
So you just have to be careful when you do your exponents. That's why I label them. If we would have called P 0.18, because that's technically success if they live, right? Like if P is
Then it would
success,
be
then it
3.
should be 0.18. Then it would be 3, right? So just be careful. That's why I label. So you have to be careful. Okay? So there's that. Yes, sir.
The exponents didn't matter on which one they were on.
Yes, they do.
No.
They
It's
do.
different.
It doesn't matter which one you do first, right? Like I could have put 0.18 to the third power first and 0.82 to the second power or to the first
the
power
3 has
second.
to go to
I could
the
switch those two around,
18 and the
but
1
the
has
3
to
has
go
to
to
go to the
82.
18 and the 1 has to go to the 82. Yes. Okay. All right. If you do that, then you get something. I don't know what it is. 0.0191. Awesome. So I have a 2% chance. 2% chance that
You know what that is?
this thing is gonna, like, I'm gonna have 3 out of 4 live.
That's
Why is that
significant.
number so low?
Because
it's
you have a high
significant.
Because I have a high kill rate. The chances that 3/4 of them live if I have such a high kill rate is like slim to none.
Significant.
So would it be significant if I had 3 out of 4 live, given my kill rate? Yes, because that's less than 5%, right? Do we see how this works? Okay, so what I'm gonna do is let's go up to the top, and I'm gonna go to my chart here, and I'm gonna fill in X, and I'm gonna fill in P of X. Up here to the very, very top. We're gonna fill in our X and I'm filling our P of X. What, if we have 4 trees, what could our X's be? I could have 0 live, 1 live, 2 live, 3 live, 4 live. Okay, we're talking about 0 being live.
So 0, 1 to 0 to 4.
Yeah, we'll talk about 0 being live. Or like the X's being live. We could make this table. We could make this table based on either live or die. Let's go ahead and say live. Because we're talking about 3 living. Whatever. Okay? All right, so where does the 0.0191 go? On the 3. 0.0191. That's what we found for that one. Okay? Good.
Now we just sit here and
Now we just sit here and do all the things, right? Okay? So if I'm trying to find, like, let's say this first one, I would do 4C0, 0.82 to the something power, 0.18 to the something power, right? If I want 0 to live, where does the 0 go? On the 0.82 or the 0.18?
0.18.
0.18, because my live rate is 0.18. That means on the 82 goes
4.
4, right?
It's
Yeah?
0.45.
Okay, then I go 4C1, 0.82 to the something, 0.18 to the something, right? 1 live, 3 die. Then I do the same thing, 4C2, 0.82 to the, I guess it'd be 2 and 2, it doesn't really matter. 0.18 to the 2. We've already done 3, and then this would be 4C4, 0.82 to the 1, and 0.18 to the 4.
Are we supposed to write those in the
You don't necessarily have to write them down.
Are we writing for them in the formula?
You don't have to write them down. Well, I mean, I just put them off to the side. Yeah. Yeah. So he can bleed over, but we are gonna put a formula here. So make sure you have enough room. It's a small formula.
Shouldn't that be a 3 above the 0.18?
0 live.
Oh, this should actually be a 0.
All die.
That should be a 0. 0 and 4. Yes, good call. I didn't do that right. Okay, does
Yeah,
somebody
'cause
have
this
these?
is the live. This is the live. Right?
Yep.
Hang on. I have some, but give me just a
Now,
second.
the nice thing is if you have a calculator that is like good-ish, I mean yours is, but I don't know why he doesn't do that. I should reset him and see if he works. But if you have these formulas typed in all at one shot, you could just go back through and
Okay, are you
move
ready?
numbers around. Okay.
Are you
Okay, we
ready?
got, yes. You got them all?
Yes.
Oh, look at
For
you.
0, I have 0.452. I have 0.397.
Okay.
I have 0.131. And then for the last one, I have 0.0010,
Okay,
which I gave you an extra
They
decimal.
have to
So
add
you
up
can
to
get rid of
That's
the
fine.
last 0.
that's fine.
Is that true?
That's all right.
Or not
What?
true? Do they add up to 100?
Do they add up to 100?
I can add them all up.
I don't know.
for you.
Do that real quick. While we talk about this, which percent is highest? They don't exactly add it? 100?
Well, the
Almost.
first few, like,
First one's 0.
Yeah, well, this one we did 4 decimal places though too. So we could have just stopped it. There you
Here,
go.
I'll add up all,
So we do this.
like, the entire number.
Then that does add up. So if we delete the, if we go the same number of decimal places, it does add up.
4, 5.
If it ends up being 0.99, that's fine. It's just a rounding error. If it ends up being 1.01, that's fine. It's just a rounding error. Okay? Or not a rounding error. It's just a coincidence rounding because one of them, you know, whatever. Okay? All right. Now, these two are the highest. Why are those two the highest categories?
They're the closest to
Because we're talking about my live rate. What's my live rate? 0.18, right?
1.4.
And that would live in between 0 and 1 out of 4, right? 1 out of 4 would be 0.25, right? This is 0.25, and this is 0%. This is 25%, and this is 0%. And if 0.18 is my kill rate, it's going to be in between those two. Does that make sense?
Wait, how's your
That's the highest? Not my kill rate. Did I say kill rate? I meant live rate. Whatever. Anyway, so that's why those two are the highest. Got it? That's my table. Woo! Yes? Good? What does that add up to be? Is it 1 exactly?
No, I got 1.4. So I think I
Are you
added
sure?
some stuff wrong.
I don't know. 0.452 plus 0.397 plus 0.131 plus 0.019 plus 0.001. I got 1 exactly.
Oh,
Yeah. You might have like flipped a number around.
I think I did.
Yeah, so it ends up being 1 exactly, so it's perfect, okay? All right, now, that was the table all filled in, right? Like we did the formula for everything, okay? Now, how do I find the mean?
You
Like the
multiply and
average.
add.
If we're talking about the mean number of like ones that live, right? Okay, we take, yep, you're right, for the formula, we take the sum of all the x times the p of x's, okay? And then over here, let's
0.
label out, maybe you don't have to do that.
9, 7.
This little fancy thing means sum. The x means, I'm going to call it r equals x equals, these are all of your
variable things?
variables, like, what do we call them? I'm going to say first column of the table. Okay, it's like how many out of 4? P of x is the probability of each. Okay, probability of each x. Okay,
Hold on.
so
Can you go back?
I'll zoom out a little bit.
Okay.
So I add a column onto my table, and I do this. X times P of X. Whoop. So my solution's going to kind of like bleed over, I guess, a little bit.
You ready for this total?
Okay, if I take 0 times 0.452, it's 0. If I take 1 times that, it's 0.397. If I take 2 times that, that's 0.262. If I take 3 times that, that's
573.
0.057. If I take that times 0.4, that's 0.004. And if you add them all up, you get what?
0.7203.
0.7203. Okay,
Hold on. Wait, why is that only, is that supposed to equal 0?
no. The sum of all of those is 0.7203.
Are we adding any more columns in this table?
No, we'll add a column, but we'll put it down here.
Okay.
So, okay, what does that mean?
That's our mean.
If for trees, the average number living equals 0.7203. Not even one whole tree lives. I have 72% of a tree that will live out of 4, according to my kill rate, right? I have an 18% kill rate. That means 72% of my trees, like,
Can
that
we
means
go back
72%
over
of a
to
tree
the
will
formula
live.
and stuff?
The rest of the other 3.28,
Third, 3 and
3 and a quarter of the trees die out of 4. So I have 3/4 of a tree that live. Okay?
And this guy
All right. I'm gonna like lose track. Did we get out of 23?
X
Yeah.
Yeah, okay. All right, so we got some time.
1 P of X is probability. Okay.
Okay, variance and standard deviation for that same table. I want to find the variance. Variance, I'm gonna use both of these to write the formula because it's gonna be kind of big and long. Okay, so the variance is equal to what symbol do we use for variance?
The
Sigma squared. Yep, and that is equal to the sum. I'm going to do a bracket. The sum of all the, do you remember what this is? You take x minus
P of x.
mu.
Yeah, mu.
Maybe I should have put the symbol up here. Mu is equal to, if you want to add that in there, you can. Mu is equal to, because that's what we call it, if you want to use the symbols. Okay, to find mu, you take the sum of x times p of x. So I just added this guy right here, if you want to put him in there. I take x minus mu, and I square it, and I take it times p of x. And I do that for all of them, and then I add them up.
Hang on.
Okay.
No.
Eli, you better be writing this down, kiddo. My coffee is gone.
Get a Dr. Pepper.
I know. I think I still have some left in here, though. I do a little bit, a little bit.
You have 2 cups of coffee?
This one is just milk with a splash of cold brew, so it doesn't hardly have any caffeine in it. But I was cold today, so I went and got just a little bit of hot coffee. I was freezing. All right, if we're trying to find standard deviation, what's the symbol for standard deviation?
Sigma.
Sigma. And how do we find it?
Just square.
The square root of that. Can I just do that?
Wait, hold on.
You just take the square root of that rather than rewriting it again. I'm just going to say the square root of that junk. Okay, all right, are we ready to fill this table in? I will tell you, this bottom one takes like 2 seconds to do, that last row. So we're doing the hard part right now. We're in the trenches. We are doing, so this, imagine that this is like a 4th column of a table, right? But I'm going to put it down here, okay? So we have x minus mu squared times p of x. And that's this column of this table, right? So this is like the 4th column of the table.
Times P of X.
Yep. Yeah, sure. Yeah, yeah. Okay, so for the first row of the table, what is x?
0.
0 minus
0.7.
0.72. Let's just go 0.72. We'll just say 0.72.
So then 1 minus
Squared times, what's p of x?
452.
0.452. Yep. And we do that guy. Okay. And that is equal to something.
Hang on. Oh wait, we gotta square it.
Oh, yeah.
Have to Square it.
0 minus 0.72 squared times 0.452.
0.234.
Yep. I got 0.234. Okay. All right. Second row. What's he look like?
1
1 minus
0.7
0.72 squared times 0.397. Are we getting how this table works?
Okay. 1 minus
397. I got 0.031. 0.031. Next row. 0.031.
0.031.
Next row. 2 minus 0.72 squared times 0.131. Do we see what we're doing?
2.08131.
I get
Nope.
0.215. All right, what's my 4th row look like?
3 minus 0.72.
3 minus
squared.
0.72 squared times.
0.0573.
No.
Oh,
No.
oops. I mean 0.019.
0.019. Yep. Yep. You're looking at the wrong column. That's fine. 3 minus 0.72 squared times 0.019. And I get 0.099. Last one. This is a tedious process, guys. 4 minus 0.72 squared times 0.001. What?
Yeah, it's 0.0992.
Is it again?
What? The number 3 is.
Oh, whoa. Ah,
What do you mean, Ellie? For number 3? She is 0.099.
yeah. They couldn't. They can't read my handwriting. That's what they're asking for. 0.003. Boop. Okay. 0.234 plus 0.031 plus 0.215 plus 0.099 plus 0.003. 0.582.
0.011.
That is the variance, which is sigma squared, which is 0.582. If I want the standard deviation,
Wait, hang on. I gotta get the sum of all that. Oh boy. 2, 3, 4 plus 0.031 plus 215.
0.763. Variance, standard deviation. Ouch. Ouchie.
What is it, 0.763?
Hang on, something ain't right.
0.763. All right, you got a little bit of room down here?
No.
Not really, but kind of.
Just a little bit? Just a little bit. Whoop. Okay, we're going to get done with this.
Hang on. Did you get 0.5898?
I got 582.
Or what?
That? I got 0.582.
Scoot that
She
way.
did 17. You probably did 7, 2, and 3, didn't you?
Yeah.
Yeah, that's fine. That's fine. You leave yours. It's fine.
Okay.
Okay, and you take the square root of that to find the standard deviation. Okay, last thing I will say. What was the average, by the way? The average number of things living out of 4? 0.72. So if I have 4 trees, 0.72 is the average number that will live, yeah? Okay? All right, then if I'm trying to find significant values, I add the standard deviation twice and I subtract the standard deviation twice, true? Okay, standard deviation is 0.763. So I'm going to take and subtract 0.763 and subtract 0.763 and add 0.763. You don't have to write that down. Plus, don't write this top part down if you don't want to. 0.72. If I subtract 0.763, I'm going to say times 2. I'm just going to subtract it twice. I get negative 0.806. If I add, we'll explain what this means here in a second. Plus 0.763 times 2 is 2.246. Okay.
Did you get the 0.72 from the top?
0.72 is the average. The average always goes in the middle. Yep. Correct. So if my kill rate is 82%,
It's average.
and I'm talking about killing out of 4, 0, 1, 2, 3, 4, right, whatever, okay? Is it significant? Would it be rare for me to kill or have 0 live? Is what I should say.
No.
Would it be rare for me to have 0 live? No, 0 lives here, right? So it would not be rare. Not uncommon, not significant. Okay? Would it be significant for me to have 1 live?
No.
No, not significant. Would it be significant if I had 2 live? No, because 2 lives over here, so not significant. How about if I have 3 live?
Nope.
Yes.
No.
Yeah,
Where?
yeah.
What number are you looking at?
Anything beyond here, 2.246. If I had 3 live, 3 is outside of that threshold.
Oh, because it's
So-
0.099.
Given that my kill rate is so high and you give me 4 trees, it would be like a wow, holy crap thing if I had 3 live. Does that make sense?
What number are you looking at?
Like
to get
that is a high number of live given the fact that I have such a high kill
Are you
rate, right?
looking at your P of X or?
I'm
your-
looking at this thing right here. Like where my cut
no,
marks are.
like what number are you looking at for 3?
I'm looking at where it lives on this thing,
on
right?
the line.
3 is above 2 standard deviations above. Okay?
Got it.
Also, if I look at 3 on this chart, I guess that's not less than 5%. Right? But maybe our rounding is off too. So, oh no, that's X times P of X. We're looking at this number right here. That number is less than 5%, right? So it would be significant to have 3. It would be significant to have 4, right? If I had 4 is even further beyond. That's going to be rare. Like this is not going to happen very often. Rare equals significant. Does that make sense? You don't have to write this down. Okay? I'm just going through all the things, right? So because my kill rate is 0.8, what did I say? 0.8 something? 0.82. Because I have such a high kill rate, if I had 3 out of 4 live, you would be like, holy crap, I can't believe that happened, right? Okay, good? All right, last thing. Okay, last thing, and this is going to take like not very long. All right, we just found mean, variance, and standard deviation given the table. That is absolutely disgusting, right? If I'm given the table and I have to find the mean, variance, standard deviation, it's gross. But if I'm given this stuff and I have to find mean, variance, standard deviation, it's really nice, right? The mean is equal to mu, and to find mu, I take n times p. To find the variance, I take a variance is sigma squared, and I take n times p times q. I'm bleeding this all over because we've already written down up here what the important information is. The standard deviation is equal to sigma, which is the square root of npq, or just that number right there, all right? So, given the n and p and q and stuff that we've been doing this whole time, mu is equal to n times p. What's n?
Total.
4.
Oh.
And actually, I'm going to switch my p around. I'm going to do 0.18 as my p, because we're talking about, up here we talk about live, right? So I'm going to say my p is 0.18 this time. Okay, because we want it in terms of live. So if I take 4 times 0.18, what do you get?
Oh shoot. 4 times 0.18. You get 0.72.
Guess what?
That's our average.
That's the same as what we got up there when we did it table, right? But we got it super faster, right? If I do the variance is sigma squared. I take n times p times q. 4 times 0.18 times 0.82. I don't know what that is, but I can guess.
0.5904.
0.5904.
Yeah.
Okay, what did we get above?
5.9.
0.582, okay? Which is probably due to rounding. If I take the square root of that,
I got 0.5898, so I got 5.
what do we do if we take the square root of that?
Teachers, if you still have down slips to turn in, please let the office know at this time.
0.768.
Again, there will be a junior high boys basketball
gonna say
meeting in the
square
last
root,
10 minutes of lunch.
0.5904,
Today, that'll be in the gym.
which is 0.768.
Travel suits are in, stop by Mr. Armstrong.
Okay.
to pick them up.
Look at that. If we are given the NRPQ, doing mean variance standard deviation is so much faster. If we're given the table, we got to do that method, which is ugly. But we get the same answers, right?
Couldn't we just
Woo!
use we have the information that we need to do?
Yeah, so if we were to choose, I would definitely do this the bottom round. But sometimes, if you're only given the table, they don't give you your NRP and Q. They only give you the table, right? So if you don't have that, you have to do the ugly, awful method up at top, right? Yeah, given a choice, if I have both options, you better believe I'm going to choose the bottom one. Yep. But if we don't have that, then, you know, we're kind of SOL. Okay? Oh, I'm still recording. Goodbye, people. Sorry this is a long video.
Tell me.